If you're thinking what I thought when I first read this, it's that, what in the world is a pentamino? I looked it up, couldn't find it in dictionary.com. So I guess we're just going to have to go with their sketch and believe that that is in reality a pentamino. It says that there are 12 non-congruent shapes, and each of those is called a pentamino. Now each of the pentaminos has 5 square units. Do you see that? 1, 2, 3, 4, 5. Each of them has 5 square units, okay? So let's look at letter A first. A pentamino solution is any way of fitting the 12 pentaminos. There's 12 of them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, there's 12. What must the area of the solution rectangle be? In other words, if we put all 12 of these together, into a rectangle, how many squares are there going to be essentially? Well, people, this is not that hard. There's 12 of them, and in each pentamino there's 5. 12 times 5 equals 60 units squared. Easier than you thought, huh? Okay, letter B. What are the geometric probabilities for each pentamino that a square chosen at random from a solution will be in that pentamino? Remember that probability is favorable over the total, okay? So our total is going to be our total. How many pentaminos are there? Well, there's 12, right? Okay, and the reason we know there's 12, that 12 is the denominator, is that it says, what are the geometric probabilities for each pentamino that a square chosen will be in that pentamino? So we're not talking about individual squares necessarily, we're talking about the probability of ending up in any given pentamino, ending up in the W pentamino or the T pentamino, etc. Okay, so what are the geometric probabilities that a square chosen at random, so we have one square chosen at random, well, that probability is going to be 1. So any one square, we'd have a 1/12 chance of ending up in the W pentamino or the Y pentamino, and so forth. Letter C. In this partial solution, some of the pentaminos are fit together in a smaller rectangle. That, when it's saying about partial solution, that's this right here. In other words, a partial, we've only used up 1, 2, 3, well, we've only used up 4 of the pentaminos to create this rectangle. And it is a rectangle, by the way. I'm going to point out here that this is 1 square, 2 squares, 3 squares, 4 squares, and 5 squares. So this is a 5 across, and then this is going to be 1, 2, 3, and 4. And you can tell that, I can tell that this is 4 because this shape right here, do you see this one right here? That is the V pentamino, and that fit right in here perfectly. So this little yellow one that I've got shaded in here is the V pentamino, right? You could figure out what the other pentaminos are that they put into this rectangle here, but I'm not going to take time to do that right now. We're being asked, what is the geometric probability in this rectangle of the V pentamino? Well, if you're just looking in here, what's the total number of pentaminos represented here? It's 4. So 4 goes in our denominator. What is the probability of the V pentamino? There's only one V pentamino, so it is 1/4, favorable over total. What's the probability of the T pentamino? Well, where's the T pentamino? This is the T pentamino. Oh, how clever. They made this look like a T. All right. Looking like we are kind of following this pattern here. Are you catching on to that? Letter C, letter P, they kind of look like the letter that they're named after. So we're looking for the T pentamino. Do you see the T pentamino in this rectangle? Do you see the T pentamino? No, I don't either. So what's the probability of the T pentamino? 0 out of 4, which is to say 0. Hopefully that makes sense.